the link, this link of the data set, which is this one. Then it will ask you for your after running that, then it will ask you for your username. So you put your username over there, then it asks for a Kaggle key. You can find a Kaggle key over here, go to settings, and then in the API section, you create a new token. After creating a new token, it will download a JSON file. So when you open the JSON file, you will find your API key there. You put that there, and it will download the dataset. Then this is just a quick revision for your pandas as well. So after doing that, you do df is equal to pd.read underscore csv. Your dataset will come over here. Then you just copy that path and paste it over here. And this is df.head. It shows the first. So I've given the parameter as 15. So it will show the first 15 values of the dataset. This is df.tail, which shows the last 15 values of the dataset. So you can see it has like 1,000 rows. So it's a pretty big data set. So that describes the data set, like what, how many count, mean, standard, mean, and all the stuff. Then this counts all the null values in the data set. This gives us some of the null values of the data set. This gives the gives the data type of the columns of the data set. Like you can see, the product num is an object, category is object, price is float, rating is float, num reviews is integer, and all that. This gives the overall info of the dataset, df.info, product name, category, price. These are all the columns. These are the null, non-null, and non-null count. This is the data type. So all this can be summarized in one by using df.info. So df.columns gives us all the column names, which can be used in Seaborn matplotlib to plot graphs, which we'll look at later. df.index gives you all the indexes from 1 to 1000, which 1000 rows, 1000 rows are there, as you can see. So it gives all those there. And this is sorting the data frame into this is descending order. The default would be an ascending order, so we set that as false to make it a descending order, to sort it in descending order. Then yeah, that's it. So this shows the category of this shows only the category column along with the product ID. This command over here, and I'm just printing it over here. Yeah, so rest is just your pandas only. Now we'll start with C1. So there are 4 mainly tools used for data visualization. One is Matplotlib, second is Seaborn, third is Plotly, and 4 is Pandas. You guys are familiar with Matplotlib and Pandas already. Now you will learn about Seaborn. So Seaborn is a Python library for data visualization built on Matplotlib. So it's an extension of Matplotlib, you can say. So as you can see, you need to import Matplotlib as well to work with Seaborn. So Matplotlib is used to plot 2D and 3D graphs, while Seaborn is used to plot statistical graphs. So with Seaborn, you will learn you will plot all the distribution plots, which will be helpful for your data analysis as well as machine learning. Since Seaborn builds on Matplotlib, you can use this tool together to create a powerful visualizations. So we import Seaborn as SNS. You can choose whatever you want, but SNS is a common name which everyone uses. Seaborn is used to plot data distribution plots. So what is data distribution? So data distribution is a list of all possible values and how often each value occurs. Such lists are important when working with statistical and data science. The random module offer methods that returns randomly generated data distributions. So from NumPy, we can import random to give us random values from a given size, from a given size. So I'll just start with a different distribution, random distribution. So a random distribution describes how values or outcomes are spread out over a range when selected randomly from a set. So basically, we have given a set of 3, 5, 7, 9, and we are given a size of 100. So it gives us randomly distributed values of 3, 5, 7, and 9. So so basically a random distribution is a set of random numbers that follow a certain probability density function. So a probability density function is a function that describes a continuous probability. That is a probability of all values in an array. So in this code, you can see that random.choice, I've given four numbers, 3, 5, 7, and 9. I have I've given them distinct probabilities 0.143, 0.345, 0.647, and 0.049. So this will so when I print x, it will give us 100 numbers of 3, 5, 7, and 9 using this probability. So that's all about random distribution. Normal distribution. Normal distribution, it is a continuous probability distribution. Uh, it is a continuous probability distribution that is symmetric and bell-shaped. So this is what I mean by symmetric and bell-shaped. As you can see this curve. It is also known as Gaussian distribution after the German mathematician Carl Friedrich Gauss. It is a probability distribution of many events, example IQ scores, heartbeats, etc. Most of the data points in a normal distribution cluster order and cluster are order and mean. So basically, it means that the data points are the most data points you will find are at the mean or the average point of the curve, as you can see over here. So hence giving it a bell shape, as you can see, the most points are over at the mean of this plot. So this is a KD plot. So we are using Seaborn over here with sns.kd. So what KD is a KD is a kernel density estimation plot, which is used to make smooth curves that show how likely different values are within a data set. So next up we have binomial distribution. Binomial distribution is a discrete distribution. It describes the outcomes of binary scenarios. Example, toss of a coin. It will either be heads or tails. So basically 0 or 1. So it basically gives so basically it has three parameters and number of trials, which I've given here as 10. Probability of occurrence of each trial. Example for toss of coin is 0.5. And the size of the return array. So I've given it as 10 integers. So it will give us 10 numbers from starting from 0 to 9. So yeah, so it gives us a probability of how many times a coin can be flipped. It is used for that as well. So it is a discrete probability distribution that that describes the probability of each number of a discrete random variable. So discrete random variables means the numbers are not continuous, like 1, 2, 3, 4. They are like 1, 3, 5, 7. They are not at all linked together. They are just discrete variables. So binomial distribution is helpful for that kind of plot. So here we are using another Seaborn plot, which is a DIS plot, which is by default a histogram. So yeah, so when we plot random to binomial, which is a random function from NumPy, it gives us this histogram over here, which is a discrete histogram, which it is not linked together. As you can see, it's 0, 2, 4, 6, 8. It is not like 0, 1, 2, 3, 4, 5, 6, 7. It's distinctly different from each other. You can set this to KD as well, this plot to KD, but for binomial, it is recommended to use this plot. and then by default it creates an histogram. You can set it to different values as well. So Poisson distribution. It is a discrete probability distribution again. A discrete probability. So it estimates how many times an event can happen in a specific time. Example, if someone eats twice a day, what is the probability he will eat thrice? It has two parameters, lam, rate or known rate of occurrence. Example 2 for the above program. So here we have a known rate of 2 and size, the shape of the returned array. So yeah, so here I'm basically giving random dot lam equals to 2. So basically 2. 2 is our known number of occurrences over here. And returns us as random variables to give us a probability function. This again a discrete graph. So I am again using a disk plot, which by default gives me a histogram plot. And here I've taken the shape of the array as 1000 to give us a better value for graph. And the distribution came out to be like this. So a uniform distribution. It is a type of distribution where all outcomes are equally likely. So basically, imagine randomly picking a number between 1 and 10. The likeliness of the number between 1 and 10 is 1 by 10. So all the numbers from between 1 and 10 it's the same probability of 1 by 10. So it is a uniform distribution. So for this we have three parameters. For lower bound default is 0, upper bound default is 1, and the size is the shape of the return array. Here I have given 2 by 3, which is a multi-dimensional array, as you can see over here. Here I've again taken a KD plot because uh, it is a probability which is continuously occurring. It has the same probability of occurring, so we have taken a KD plot to give us a better example to plot this instead of histogram, which would just be bars which have the same meaning. Like everyone has the same probability, so every bar would just be like the same only. So we've taken a KD plot, which gives us a better visualization for this about distribution. Logistic distribution. Logistic distribution is used to describe growth. So basically what this means is that first of all it is a continuous probability, which means it starts from 1, 2, 3, 4, 5, 6, 7, 8. It that is used to make this is used to make your ML models grow, and it is also used in linear regression. Con- Linear regression, logistic regression, neural networks, etc. It has three parameters: log mean, where the peak is default, which is 0; scale, standard deviation, the flatness of distribution, which again default is 1; the shape of the return array. So I've again taken a multidimensional array over here. The log, which is the mean, I've taken that as 1. I've changed the default from 0 to 1. And the scale, which is standard deviation, the flatness of the distribution, I've changed that from default to 1 to 2. So it gave me some random values over here because I've used random. So for plotting this, we again use KD with the size of 1000. So as you can see, we are constantly using KD plot and the disk plot in different distributions. This is very important to note, as KD plots are very important as well. You will use them more in your ML models if you plan to make them. So, logistic distribution is one of the most important one, as it is extensively used in machine learning. So multinomial distribution. This is basically a generalization of binomial distribution. So what that means is that it describes outcomes of multinomial scenarios like binomial, where scenarios must only be 1 or 2. This gives more number as example for dice roll outcome. So there are 6 possible outcomes for die roll. like and all of them have the same probabilities, 1/6, 1/6, 1/6, 1/6. So here I'm again taking a random from n equals to 6 to be the probability of 1/6 all having. So it gives me values of this of the variables in probability of 1/6. So all are the equal chance of coming out. So when plotting a graph like this, it gives me different probabilities of all of them. As you can see, all of them have the same kind of plot. They have the same probability. That's why I've chosen different colors to make it more representative for 0 to 5. But as you can see, they all follow the same line. They are they all have the same probability. So again, your KD plot is again helpful over here. Exponential distribution. So exponential distribution is used for describing time till next event. Example, failure or success. I will explain this a better way. It helps us understand how long we have to wait for an event to happen when the event happens constantly but at a constant average rate. For example, I will give you an example to make you understand this better. Imagine a friend is calling you every 15 minutes. You have been waiting for say 10 minutes. The exponential distribution helps you find out the probability that you will get the call in the next 5 minutes. So again, it needs two parameters, which is scale, inverse of rate, C lamb in Poisson distribution. So in Poisson distribution, lamb is rate or known of occurrences. In in exponential, it is the inverse of rate. So it defaults to 1. The default is 1. I've changed it to 2 over here. The size, the shape of the return array, again, it's a multi-dimensional array. So yeah, these are the random values it gave us. I'm again using a KD plot with exponential. You can see the graph over here. It peaks at the beginning and then it slowly fades out. This is this shows us density of the on the y-axis with the density. So it shows us the around at the beginning the density is very high and then it slowly fades away. Chi-square distribution. Chi-square distribution is used as a basis to verify the hypothesis. Now, what does that mean? The chi-square distribution is a continuous probability distribution. This is again a continuous probability distribution that that is widely used in statistics, particularly in hypothesis testing and in constructing confidence interval. Imagine, okay, I will give you an example for this if you to understand what I mean. Imagine you roll a fair die and count how often each number appears. You would expect each number to come up approximately the same number of times. The chi-square test can help determine this. So it is again given by two parameters, df, which is degree of freedom, and size, which is the shape of the returned array. From again, I'm using random numbers over here. So it has a random as you can see from NumPy, I've imported random. So it has a lot of functions as well. Like you can see, it has a direct exponential function. It has a direct multinomial function. It has a direct logistic function. It has a direct uniform function. It has a direct Poisson function. It has a direct binomial function. And it has, and for random, I will choose a choice. But yeah, so it has all the distributions direct options. So you can use NumPy for a lot of things. So basically, your data analysis starts from NumPy and it keeps on going. So from day one when you started about NumPy, you kept on building your skills all the way till now, which you will now use as we are currently using NumPy, Pandas, and Matplotlib we will soon use ahead of this, and we are currently using Seaborn, which to plot us this distribution graphs, KD, and this plot mainly. So yeah, so again I've chosen uh, random values for the chi-square test, and it gives random values. So again, you can see the distribution for this. I've taken the DF2, which is the degree of freedom, as 2, and the size as 1000. So as you can again see the graph. It again is the density at the highest at the beginning, and then it slowly goes away. So these are all the distribution graphs that you can learn using Seaborn, that you can make using Seaborn. But that is not all you can do with Seaborn. Seaborn, as I said, is an extension of Matplotlib, as you can say. So we can plot Matplotlib graphs using Seaborn as well. So let's say I have taken two lists with one as var and one as var underscore one. One has 1, 2, 3, 4, 5, 6 as values, another at 2, 3, 4, 1, 5, 6. We can, using pandas, first of all, I've just given us a nice to view what it means to as the var one. This is just ordered way of writing this. This code helps us write that. And with using SNS.line plot, we can make a line graph. As you can see, this PLT just shows from your matplotlib. So matplotlib is very important for C1. Otherwise, you won't be able to show your graphs. So basically, this shows the line graph. As you can see, that it's say when your x-axis is var and your y-axis is var when it's going. So when your x-axis is 4 is 0, your var one is 1. So this gives us a line plot of this two lists. Now working with the data set. As I've previously mentioned, you can use the open data set to download the data set, and using pandas you can read the CSV file which is the data set which will come over here, and you just copy its path and place it under this function pd.read underscore CSV. So this will read the CSV file. So using a column rating, I have done a KD plot. So a KD plot, I've again mentioned it above. It's a kernel density plot. So as you can see, it gives us the average or mean rating around 3. This helps us give us the mean rating around 3. So this is a scatter plot which uh, which I've used of which have data is from data frame, and the data frame is our CSV file. Where so I've taken x as the price. So I've taken x I've taken x as price and y as rating. So it gives us a relation between price and rating. As you can see, this rating is very abstract. You really can't figure out much about this. So we usually take head df.head and take on like top 10 products and give their rating curves to give us a more meaningful output of the visualization. Similarly for this box plot. Now box plot is another one of the ways to present your graphs. This is how box plot is look. As you can see, it is very abstract. This is very You can say this is very convoluted. You won't understand what it is just by looking at it because there are way too many values. So we use df.head which gives us a top and say 15 values, which gives us a top 15 values, and use those to give us the top 15 product name, and the price you can keep as it there, and top 15 product name you can place, which would look a lot better than this. So I will just explain the code for you for making a box plot. So this is a PLT of figure, which is just giving me figure size. So I have to adjust the figure size because this was so many of the product name were overlapping each other. If it was default, uh, figure size, so I had to change that. Then this is the box plot function for Seaborn, SN as a box plot. Again, I've taken data from DF. I've taken the X as product name, and I've taken Y as price. Uh, I've just taken X. I've just rotated the price as 90 degree to give a better visual readability. And I've taken given the plot a title, price distribution by product name. So yeah, if you're given with a data set with so many values, say, and you're trying to find a relationship with it, the best way to do it is not doing it like this, but doing D, but using the df.head function and finding the top 10 values or top 15 values of it, and then providing a relationship. You can make the mat So you can make the matplotlib plots using Seaborn as well. As I said, Seaborn is basically just an extension of matplotlib. So you can do everything what matplotlib can do, and plus do distribution plots using Seaborn. So Seaborn is a very important library to learn, as it gives a good idea of how matplotlib is supposed to be, and it helps you in your ML models as well. So here I'm making a bar plot of group data by category. So I've taken category sales. I've used the group by function of the pandas. I've taken category and sales dot sum and sort value ascending equals to false. Now, as I've mentioned earlier, ascending equals to false means descending. Since ascending is the default value, we have to change it to false to make it descending. Then I've taken top 10 categories over it. Now look, I've taken top 10 categories. Now look at this. This is way more readable than this, because I've taken top 10 categories. So I've taken categories dot sales dot head 10. Then this is to plot the graph bar plot. PLT dot figure fixed size equals to 12,6. Bar plot x equals to top underscore 10 underscore categories, which is this variable over here. Dot index. Y equals to top 10 categories dot values. Now this is the total sales. So I've taken values. This is an index to give us the name of the categories. I have this is just to give a nice look to the labels. That's why I've taken degree as 45. And this is horizontal alignment, which is taken as right. Rotate x axis label. Now I've taken label on the x axis as category, on the y axis as total sales, and I've taken the title of the plot as top 10 categories by total sale. So I've taken this is a type layout, which is another function which you can use to give a better layout for your plot. And PLT just helps you shows the figure. So this is basically the bar graph. As you can see, the bed sheets have sold the most amount of sales. Uh, then it's art and craft materials. Then motor vehicle parts. Then vitamins and supplements, then mobile accessories, then electronics, then bicycles, then bath and body, then makeup. And as you can see, the makeup and toy games are almost the same. Now we look at another type of plot, which is a correlation plot. So first of all, correlation can only be done with numerical features. So I have taken numerical features called such as price, rating, and sales. So I've given the variable name as numerical df. So numerical meaning your int or float variables. It can only be done using that. You can't use a characters here. So that's why I take only price, rating, and sales. So correlation matrix is your is a variable name, and there is a function known as df dot call. So it's a function in pandas. So when plt dot figure, I've again adjusted the fixed size to 8,6 to make it better looking. So this is a heat map. As you uh, this gives so there's a function in pandas known as heat map, which gives us a correlation matrix. So I've taken the so in the essence of heat map, I've taken this parameter. So I've taken correlation matrix, which is this variable, as a parameter. I've given annotation equals to true to give us these values. I've given a palette to the correlation matrix, which is cool warm, which is this color scheme over here. And I've given center equals to 0. I've given the title to the plot as correlation heat map of numerical features, and then plt.show. It gives us this one. So from this correlation heat map, as you can see, there isn't much we can infer from this. As price to price. So first of all, the diagonals will always be one, because price and price will be one, rating and rating will be one, sales and sales will be one. So the diagonals of a correlation heat map will always be one. And then the values over here, which is the 0.06, 0.0065, 0.029, 0.0085, are are not really that distinct to give us a proper to give us any correlation between the price or rating. So here we have price and rating. So here the correlation came out to be minus 0.0065. This is not significant enough to conclude anything. Similarly, for rating, it starts from minus 0.0065, and and, uh, and with price and rating it came to be minus 0.0065. This again not that significant enough. The sales part is again the same, 0.0029 is price. So we can conclude from this that in the data set we were given as the price and rating don't really have any correlation between them. So they are so we so it's not like that कि price अगर बढ़ा दिया हमने तो rating भी rating कम हो रही है या price कम गया तो rating ज्यादा हो रही है, ऐसा कोई relation में significant है नहीं. Similarly for rating or price, the if the rating ये दोनों तो सेम ही होगा कि रेटिंग और प्राइस और ये और सेम होगा. सेल्स और प्राइस में देखते हैं तो इधर भी ऐसा कुछ है नहीं कि प्राइस ज्यादा हुआ तो सेल्स कम हो गई या प्राइस कम हुआ तो सेल्स ज्यादा हो गई. ऐसा कोई रिलेशन उतना सिग्निफिकेंटली यहाँ पर इम्पैक्ट कर नहीं रहा. तो हम कुछ so we can't really conclude that sales and price have a direct correlation. Similarly for sales and rating, as you can see for 0.0085, again it's not really that significant. So we can't say that the more the rating, the more sales, or less rating or less sales. According to the data set, people have bought despite the ratings, sales, and price. So the heat map between all three of them is not really that useful. We can do it with other values as well, but make sure it has to be numerical, or you can change your characters to numerical as well. But that's that's quite difficult to do. So we will look at another type of plot, which is a violin plot. Now this is
Brother,
similar.
we have doubts here.
Uh-huh.
Wait, is your question whether fixed size, why is fixed size 8,6 for heat map? Is that your question, Vinayak? Yeah, you can change it. You can make it 22 by 7. I mean, comma 7. What am I saying?
And
By 7.
we can change the fixed size to anything
It
we
doesn't make
want.
a difference. It's
Yeah,
fine.
it's just to make your plot bigger or smaller depending how you want it. Just for easy viewability. Okay, so we will look at another type of plot, which is violin plot, which are similar to box plot but show the KD of the distribution. So remember KD from over here. I have explained this over here, which gives us the mean value where the more data points is at the mean. So violin plots give us that and are very similar to box plot. As you can see, this middle black bar over here is present in as it's kind of present over in box plot as well. So they are pretty similar to each other. So again, I've taken top 10 categories where DF by group by category, sales, I've taken largest 10 cells and I've given index. For again, I've taken top 10 of them. Is in if I've taken category is I've taken filtering of the data frame to include only top 10 categories data. I've filtered the data frame to include only top 10 categories. Now to make the volume plot, again I've taken fixed size. You can change this to anything. You can change this to whatever number you want. It does not matter. I've taken as 12 and comma 6 because I think this is appropriately readable, so I've taken that. So as soon as the violin plot is the function for C1 to plot the violin. I've again the data is equal to df underscore top 10, which is after filtering the data frame to include only top 10 categories data, where X is my category, you can see, and Y is my price. And Y is my price. So for PL for X6, I've again rotated this as 45 degree to make it look better. But you don't have to do that. It's just for my convenience. I've given the title for this plot as violent plots of for price for top 10 categories. I've again given the type layout, which gives us the better layout for the plot. And, and we have done plot plt.show, which shows us the plot. Now, in violin plots, the shape of the violin indicates the density of the data. So the shape of the violin, this shape over here indicates the density of the data. And the white dot in the middle is the represents the median price in that category. So here the white dot here is kind of corresponds to 300. So we can see the in electronics the median price is 300. Similarly, for toys and games, the median price is also around 300. In vitamins and supplements, the median price is around 200. In makeup, the median price is around 250, between 200 and 300. Bicycles is again between 200 and 300. In art and craft materials, is between 100 and 200. Bed sheets is again 200, between 200 and 300. Bath and body is again between 200 and 100. Motor vehicle parts is between 200 and 100, and mobile phone accessories is between 200 and 300. So it gives us a better representation than box plot, and it gives us the density as well, along with the median values. Now for the final plot, which I will show you, is the count plot. I have again taken the figure as I have taken this time 20, 15. As you can see, this is a huge plot. So to make it better viewable, I've taken the fixed size as 20, 15. I've taken count. So this is a function for count plot. This is SNS dot count plot, where X equals to data from rating, the rating column. X is your x-axis. Data is equal to df. We are taking the data from the data frame, and I've taken palette. So palette is basically color scheme of the count plot. I've taken so there are predefined palettes in C1. This is one of them where it is. So it allows this this color to the count plot. I'm just going to zoom out a bit so you can view it better. So yeah, so this on the on the y-axis we have count. So the number of ratings. So the number of ratings for a given rating, and for x-axis we have rating. So I've taken rating. So the data set has rating from 1 to all the way to 5. So these are different. So these are counts for all the ratings which were given by people. So from this plot, you can make out that the most number of ratings that people gave was 1.1. This data so this plot is very useful for giving you counts of things, and it is very helpful for finding out the most number of rating or any value. Rating can be anything, by the way, but it needs to have some meaning. So yeah, that's about it for my presentation. If you have any doubts, I will be happy to answer them.
Hriday, I think you should cover count plot again, I guess.
Okay, okay.
There's a doubt. I'm not sure what you've used for your graph, so just show
Yeah,
that.
yeah. Here, here's my count plot.
Okay, yeah,
Okay.
fine. Fair enough. The rating of all the categories. Yep.
So the rating for all the given rating is just
So,
a column in the data set.
so basically, what this specific plot is doing is, so there'll be ratings from 1 to 5. So you'll have 1.1, 1.2, and so on. So depending on that, how many people have given the rating 1 and 1.1 and 1.2. That's basically what this count plot is showing. So that's that. How to add color?
Well,
I think you use CMap here, right? Palette.
I've used palette over here.
Uh,
I've used CMap in correlation
yeah,
method.
yeah, correct. Yeah, yeah, perfect.
So there are predefined palettes available in Seaborn. You can search them
Add
online.
Inferno instead of Word is just to show them एक बार.
एक सेकंड उसके लिए मुझे सब कुछ इंपोर्ट करना पड़ेगा.
Oh, okay.
Uh,
First, एकदम first. हाँ.
वेट मुझे डेटा सेट भी.
Okay. Did you show them Kaggle का एक बार?
हाँ हाँ मैं एक और बार एक्सप्लेन कर देता हूँ कि कैसे करते हैं. मैंने स्टार्टिंग में किया था बट लाइक आई गेस मोर पीपल जॉइन सो आई विल अगेन एक्सप्लेन इट. सो बेसिकली दिस इज ओपन डेटा सेट्स करके एक लाइब्रेरी है फंक्शन पाइथन में विच अलाउज अस टू import data sets from Kaggle. So basically, you import open data sets as OD. We do od.download over here, and we insert the link of the data set. So this is the link. So this is the data set we are currently using in this presentation. So I have taken the od.download and given the link over here. Then when you run this, you will be prompted to enter your Kaggle username. And when you create a Kaggle account, you will find a Kaggle username over here. Then you enter that. You will be prompted to enter Kaggle key. Now to enter Kaggle key, all you have to do is go to your settings, scroll down, go to API, create new token. It will download a JSON file. When you open the JSON file, you will have two values, your username and API key. Copy the API key and paste it over here. Then after doing that, it will download the dataset. So after download dataset, you using pandas, we create a variable called df, which is data frame, and using a function pt.read_csv, we give the file path over here. The file should come over here in this section. You can just right click it and copy the path, and it will load and it will read the CSV file, and then you can perform your data analysis on it. So this is one of the easiest ways to import data set without on especially on Colab. Otherwise, you would have to import the CSV file again and again, because on Colab it disappears after after every runtime. So if you get disconnected, you will again have to re-upload it. I mean, you will have to do it again, but instead of just uploading it, this is way quicker than that. So any more doubts?
Yeah, yeah, Mangesh.
Can you explain the output of multinomial function? About
Uh,
time
yes, your
Sorry,
dimension.
audio is distorted.
sorry, I could not hear you.
Can you explain the output of multinomial, which was of dice number of dice thrown 1/6, 1/6 plus
Oh,
1?
multinomial.
Yes, yes.
Wait a minute. So again, what a multinomial distribution is, it is just basically a generalization of the binomial distribution. It describes the probability of obtaining set of outcomes in experiment where each outcome fails in several categories rather than just two. So basically, in binomial distribution, you would say, for example, in binomial distribution, I've given the example of coin toss, which only has two probabilities, either heads or tails. In multinomial probability, you can have multiple of them. Example for dice roll. Dice roll has six probabilities for six numbers. For 1, 2, 3, 4, 5, 6, you all have 1 by 6 probability for each of them. So this is basically so that's basically the difference between them. And this so as I've given the probabilities as 1 by 6, the plot came in the same way. Or if I have given different probabilities, it would have given different lines.
What does the x-axis represent in data?
The x-axis is just your numbers from n. I've given n equals to 6, right? This
Yes,
is
yes.
written in there. Any more doubts? So if there is nothing, I can. Should I stop the screen sharing? All right. Then. Um, so the project about the data science would include all the things you have learned about till now, from starting from NumPy all the way from basic of Python to all the way to Seaborn. So you can use that in your resumes as well. It is a very important. It is basically a basic of your data science journey.
Yeah, Niyati, right. So I'll tell you a couple of things. So basically, we'll be taking a data set to begin with. I'll have a few conclusions drawn out from the data set. So see, the basis of data science is that you have to derive some meaningful conclusion from the data that you're working on, right? Let's say you're visualizing your data using Matplotlib, Seaborn, and so on. If you're not getting a conclusive proof as to how the data set will have real world impact, whatever you are doing is meaningless. So that is okay. Wait, sure. Yeah. Sivan, I haven't heard through too many things on White here. Is it like a new library? Not really, Shaurya. Yeah. Back to Niyati. So yeah, basically we'll be working on that data set in that manner. And what I'll be doing tomorrow is, so I'll be taking your session tomorrow. We'll be starting off with one or two questions, but by the end of it, I'll be asking you guys as to what you're expecting to get out of this data set, and we will code along. Basically, I'll type that code in front of you if necessary. All right.
So is there will be any kind of submission or something?
Not tomorrow. See, we want to give you guys adequate time to actually work around a data set and present your project in the future. So we'll be doing that later, not now. Tomorrow is just a short questionnaire kind of thing for you guys. All right. Yeah, you guys had doubts? Go ahead. Cool, cool. All right. Welcome, Niyati. You will create it, right? Okay, yeah, sure. All right. Welcome, Scott. Okay. Any other doubts related to Seaborn? Anything in general? Welcome, Raghav. Okay. All right. Thank you. Thank you. Thank you for attending. Yeah. Now that what will be back to session. You'll know about it in detail tomorrow, Sanika. Now I can't reveal much. So you'll know about it tomorrow. Don't worry. It's nothing. You don't have to worry about it in general. So it's just another session that we have just as a part of our event. See, it's conclusive proof that you've learned something. Basically, that final project will cover everything you've covered over the past 5 days and put it to work. So that's the basic idea behind that.
And that final project will be very helpful to you in your second year as well. If you take Python, you will have to do this. You will have to do the same thing again. So you will be one step ahead of a lot of people by then if if you do that now.
Okay. We'll have the same languages in SY as well. Yeah, so
So,
Python is a constant that you'll be having. Is
so if you are in IT branch or IT or AIDS branch, you will get to choose between three languages: C++, Python, or Java. So yeah, that's how it is. In if you're in comms branch, you will. I don't think there is Python there. It's only Java's Java and I think C++. Yeah.
uh, Shubham, yesterday's recording I think should be in the drive link. Let me check once again. I'll let you know. If it's not there, we'll add it immediately. Don't worry.
Python could be in the object-oriented part, which is the theory part, but I'm not sure about that. But I know there is Java and C++ there.
What do you recommend to choose between Java, Python, and CPP? Okay, I'll take this one. See, depends. If you're going for ML and data science, I would recommend Python heavily. Pylang, sure. That's a wonderful pastime, but sure. अभी college में तो नहीं होगा वो clearly. Okay, yeah, right. So back to your question. Python is a must for ML, data science, AI, and all of that stuff in general. Java would be a good plus to have with Python, specifically if you're targeting cyber security or something like that. That is coupled with C language. CPP is mostly for DSA and all of that. And if you guys are into embedded coding, then CPP is a must. Can we choose multiple languages? So yeah, the thing is, if you can choose one or more language. See, as a part of your OOPS subject in, let's say, second year, you can't choose multiple languages. But me being in AIDS, I'll give you an idea as to what I have. For FDS, we have to use Python. FDS is basically fundamentals of data science. That as Python. For OOPS, I've taken Java and C++. Anyways, C and C++ are quite similar in the syntax they have. So that is being covered in at least data structures for me. So in that case, I'm basically covering three languages in some format. Yeah. So sadly, comps guys don't have Python, specifically if you're in KJSC. I'm not sure about the other degrees. IT also has same as AIDS. IT has DCN. So there again, you guys will have Python. Not really an advantage, but yeah.
So
Well,
IT and AIDS are pretty similar subjects.
nah, just say it.
Okay.
Okay,
AIDS.
fair enough. It's fine.
What is the difference in SY for comms and AIDS? So in AIDS, it's mainly focused on your data science stuff. Like you will have a fundamentals of data science का एक subject होगा. Then you will have DMS as a subject, DIS as a subject as well. So these are all. So DIS is a common thing which will be in both which will be in almost every branch because it is one of the most fundamental subject. But yeah, so basically in AIDS you will get to know you will get to use Python a lot more rather than in comms.
See, Niyati, Python is bare minimum. So that you have to do regardless of whether you're choosing Java or C++. You can couple Python with Java. That's a good combo. That's a pretty safe combo to go with. C++, that is a personal choice. Let's say you want to do DSA with C++, you could go ahead with that. Many people would recommend doing DSA with C++. So yeah, but you can also do DSA with Java. Okay, one second. Is Hanika, is this will be helpful for CV or job if you're not going to placement from somewhere? Yeah, yeah, of course. See, this is proof that you spent some time learning covering the basics at the very most. See, after our 7 days, we'll be having more slightly ML oriented workshops and events. So that will be coupling this 7 days ka session with that would be like a perfect bridger course for placement level stuff. So yeah, any advice for BSc star students? Uh, Try not to get lost in the maths of it as always. If you're taking up projects, try to take up projects which are a part of competitions at the very most. So let's say you have a mini project or something of that sort. Try to build something that is already being asked as a project in hackathons, or it's a problem statement for a interview level placement question. Please, I want to ask, this will be helpful to seek a job. See, this is a refresher course. Like basically, you could do this for revision. So yeah, it is helpful, but it's the bare minimum, I would say. So you'll have to work a bit more, specifically if you're seeking out a job. Sanika, may I ask if you're like currently in, let's say, what degree are you pursuing right now?
BSc.
BSc, right? It's fine. Yeah. So see, and which year are you in?
First,
First year. Yeah, yeah. So you still have time, of course. You could use this for internships. You could even add what all concepts you've covered throughout the course of 7 days, and also add that you've worked on a final project. So that should be good enough for internships to begin with, specifically if you're in your first year. Then later on, whenever we have our events, you could always go ahead and attend them so that you'll have something more to add to your CV as well. So yeah, see, right now, obviously, you won't seek a job immediately, right? If you would have been a last year, I would have asked you obviously to work a bit more. Yeah, yeah, Sanika.
actually, I wanted to ask this certification course will be helpful outside Somaya also. Na?
Yeah, yeah, yeah.
That's why.
Of course. Yeah, yeah. Definitely.
Okay. Thank you.
Welcome. Right. Any more concepts or questions? My bad, concepts. Okay. Welcome. All right, I think that's about it. You can stop recording, I guess, now. And we can drop off this call. If you have any doubts, feel free to ask on the group.